Hi friends, welcome to this channel. Here we are going to look at problem 2780, minimum index of a valid split. So overall for this problem, we're going to use a dictionary as data structure to solve this problem. So first we're going to look at the statement, and then we are going to make some comments, and then we do the coding. And in between, we are going to encode the logic. So here it first defines what's a dominant element, which means that if the frequency of this element is more than a half of the length of the underlying array, right? So here we want to check if we can split the original array into two parts, and the two parts actually have exactly the same dominant element. If so, we are going to return the minimum index of the valid split. Otherwise, we're going to return -1. So here, actually, first comment is this. So requiring the same dominant element actually makes the problem easy, right? So you will see why when you look at the coding. And also you can look at example 1. So for example, if you do a sliding and then check index 0. At index 0, the 1 is dominant element. Well, the remaining one is 2 is a dominant element. It's impossible, right? So if you look at index 1, right? So then there's no dominant element because both appears once. So for index 2, so it's the 1 we are going to return. But here I want to use this example, give you some computational rules or hints for this problem. So here at index 2, so the left part, the length is 2 plus 1, right? And the right part is nothing but the overall length, that is 4, minus the left one, that is 3, that is 1, right? Then when you do the computation, so assume that originally you have a counter, right? So you know overall, so in the list, so 1 appears once and 2 appears 3 times. So now you can use another window to see how many elements you have seen. For example, up to index 2 or at index 2, you see 1 once and 2 twice, right? So needless to say, for dominant element, it must correspond to the maximum frequency in the window, right? So here 2 is the dominant element in the left side, because you see the frequency of 2 is 2, and then if you times 2, it's greater than 3, the length. Therefore, 2 is dominant in the left. With this information, you can all easily check if 2 is also dominant in the right, because in the right, let's see, left part. In the right part, so basically, 2 appears how many times? That is the total frequency, that is 3 minus 2, that is 1, right? Then if you compute 1 times 2, it's greater than 1. Therefore, 2 is dominant in the right. Therefore, we should return index 2. That's the thing, or the overall idea. In other words, you just need to first get the frequency counting of unique elements, and then you have a window, just look at the left. What you need to monitor is the maximum frequency element. That's it, right? So now I want to translate this line from 7 to 23 into coding format. So first I'm going to introduce a variable called n. This is just the length. So you can get the length of these nums in O1 time, but introducing this variable is just for convenience. And then we can get the frequencies of unique elements. So this is very easy. So you can get collections, counter, right? So you see nums. So let me print out this for you so that you get a better understanding. For the first example, you'll see 2 appears 3 times and 1 appears once, right? So with that printed, now let me delete that. So we are going to do the problem logic. First, I need to have a max frequency. I will assume it to be 0. And also the corresponding element, just set it to be 0, right? Because we are going to iterate. So we will have a window. So for the window, I'm going to use collections counter. And then we're going to do a linear scan. So for I in range. So the range we're going to consider is from 0, right, to we need to strictly less than n-1. That's why we write n-1 here, right? Because for the range function, it stops before n-1. So now we can see, first we are going to add the current number, nums I, into the window, right? Due to the way we initialize the window, so we can directly just implement the counting by 1. Because initially, if nums I not in this window, it's going to set the default value 0. So that's the convenience of this counter object or dictionary subclass object. So now, once you update this frequency, you need to check if window nums I, if this frequency is larger than the maximum frequency. Notice that you can only have one maximum frequency in if you think of a dominant element, but always we need to monitor the largest frequency. So then once you get this, so maximum frequency will be the max of its previous state and the current one. So I have used this elf, so I just need to set this to be window nums I. So now the corresponding element will be updated to nums I. So this is this if block. So now we need to check dominance element. So the condition will be the following. If max frequency, this is up to the index I, so times 2 is greater than the length, right? This is the one. And then this is for left side. For the right side, it will be we get the element, right? Its frequency. So we write like this. This is very safe. But here you can directly retrieve this key because element must be in this dictionary, right? So then this should minus the maximum frequency, right? So this is the frequency of element in the right part. So you minus this one, and then you times 2. You to check if it's greater than the length of the right part. That is nothing but n minus the length of the left-hand side. That is this one. So then, if this were the case, so we're going to return I, because we want to return the minimum index. So this way of sliding from left to right, once we met a valid one, we would return it. Afterwards, if nothing has returned, you need to return a -1 per the problem requirement right here. So this is the full coding for this problem. So before we make comments, let me first do a run. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes all the cases. So now I think it's time to make some comments. Here we are using a dictionary. So first we get all the information of the list. So this like, you have some pre-knowledge or similar to do some caching, right? And then you monitor the maximum frequency at its corresponding element in the left half. Because you have this overall statistics, you know what happens in the red part. And then you can check if the same element dominates in both sides. So if you find one, you return this index, otherwise you return -1. So this is the first comment. The second comment is that we have a channel. So in the channel, so we have a lot of playlists. You're welcome to check out those problems and practice according to playlist. With that said, I guess that's it for the current video. Thank you for watching.